Algebra 1, binomial expansion. This is a binomial expression raised to a power, where binomial means two terms. So, for instance, we might have something like 2x plus y raised to the power of 4. So we see inside the brackets we have two terms and the power is 4. So basically what that would mean is that we would have to take 2x plus y and we would have to multiply it by itself 4 times. And this can become very tedious and quite long to do. So essentially what we're going to use is what's known as the binomial theorem to expand it. So it's a nice, neat way of expanding it. And we don't need to know this off by heart, because the binomial theorem is page 20 in our maths tables. So the binomial theorem is where we have two terms, x plus y, raised to the power of n. And what we do then is we have n, choose or, the first term raised to the power of n, the second term raised to the power of 0, plus n choose 1, the first term raised to the power of n minus 1, the second term raised to the power of 1, plus n choose 2, the first term raised to the power of n minus 2, the second term raised to the power of 2, plus all the way till we get to basically n choose or, x to the power of n minus or by y to the power of or, plus ... all the way until we get to the very, very end, n choose n, x to the power of 0, y to the power of n. So as I said, we don't need to know this off by heart. It's all in our tables. And what we're going to talk about first is this n choose 0 bit, the n choose 1, the n choose 2, and the n choose or. So what does that represent and where does it come from? And then we'll look at an example of how to use that. So to do that NCOR, we're going to first of all visit what's known as Pascal's triangle. So Blaise Pascal would have been French from the 1600s. But of course, this was studied long before him. It just kind of seems to be associated with Blaise himself. So what his pattern starts off with is 1, and the next line is 1, 1, and the next line is 1, and then if we add 1 and 1, what we end up with is 2, and then we have 1 on the outside. If we take the next line, we have 1 again. Well, if I add 1 and 2, and then I add 2 and 1, I get 3, 3, and then I have a 1. The next line, if I have a 1, and I add the 1 and the 3 and the 3, and the 3 and the 1, then that gives me 4, 6, 4, and then we end with the 1. We start the next line with the 1 again, and we add the 4 and the 1, the 4 and the 6, the 4 and the 6, and the 4 and the 1. Then we end up with 5, 10, 10, and 1. And of course, this continues on infinitely. And what is really nice then is if we actually look at the very first one here, what we have is all of our NCORs. So what we have here essentially is 1 choose 0, and 1 choose 1. The next line is 2 choose 0, and 2 choose 1, and then 2 choose 2. And then we have 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3. Then we have 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4, and so on. And what you'll notice here is what we have is n is 1, but yet there are two terms. Here we have n is 2, and we end up with 3 terms. Here we have n is 3, and we end up with 4 terms. In other words, we always end up with n plus 1 terms. And that's very useful when we come back to our binomial theorem there. So if we're doing that on our calculator, we're using the NCOR button on our calculators. So on Casio and Sharp, they're in different places, and it's the shift button to get the NCOR button. So we would go 4, shift, NCOR button, 3, and that would give us 4 on our calculators, and you can check that yourself. Okay, so if we go back then to the binomial theorem, so now we know what these n choose 0, n choose 1, n choose 2 are going to give us and how to get them on our calculators. Well, let's look at how can we actually expand something. So if we take, for instance, the first one there, we're going to take 2x plus y to the power of 4. And we're going to be asked to expand fully 2x plus y to the power of 4. Okay, so basically that's the x term in our binomial expansion, that's our y term, and the power then is n. So because the power is n is equal to 4, we know we're going to end up with 4 plus 1. In other words, we're going to end up with 5 terms in our expansion. So in other words, we have 2x plus y to the power of 4. So 4 choose 0 times the first term raised to the power of 4 and the second term raised to the power of 0. Now if you go back to the expansion there, what you'll notice is the first term starts at n, in other words it's going to start at 4, and then it goes down by 1 each time, whereas the second term starts at 0 and goes up by 1 each time. So therefore our next one is going to be 4 choose 1, 2x, and we go down by 1, so that's 3. Y increases by 1. 4 choose 2, 2x squared, y squared. 4 choose 3, 2x to the power of 1, y to the power of 3, and I have to go on to the next line. 4 choose 4, 2x to the power of 0, y to the power of 4. So we use our calculators there to get our 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. Or if I go back here to my Pascal's triangle, we can see that we know that's going to be 1, 4, 6, 4, 1. So it's nice symmetrical there. So that's going to be 1 and 2 by 2 by 2 by 2. In other words, 2 to the power of 4 is 16, x to the power of 4. Anything to the power of 0 is 1, so y to the power of 0 is 1. 4 choose 1 is 4. Then we have 2 cubed, which is 8x cubed, times y to the power of 1, which is just y. Then we have 4 choose 2, which is 6, times 2x squared, which is 4x squared, times y squared. 4 choose 3, which is 4 by 2x by y cubed. And then we have 4 choose 4, which is 1 by 2x to the power of 0. In other words, anything to the power of 0 is 1 by y to the power of 4. So our last line then is just a little bit of algebra. So in other words, multiplying out our brackets. So we have 16x to the power of 4 plus 4 times 8 is 32 x cubed y. 6 times 4 is 24 x squared y squared plus 8x y cubed plus y to the power of 4. So again, if we check, we have 1, 2, 3, 4, 5 terms in our expansion there at the start. Okay. So the other thing to notice is obviously the first term's power starts at 4, which was n, and goes down by 1 each time. The second term starts at 0, goes up by 1 each time. And if we add each of those powers, we always get 4. So 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, and 0 plus 4 is also 4. So what happens then if we have a negative term in there? Right? So we have to be careful always with our negatives. So again, if we're asked to expand fully, go 2a minus b to the power of 5 this time. So that's x in our expansion, y in our expansion, and n is 5. So if n is 5, we know there are going to be 6 terms. So again, n plus 1. Okay. So we start with 2a minus b to the power of 5. So if n is 5, then it's going to be 5, choose 0. First term to the power of 5. Second term is minus b to the power of 0. Then we have 5, choose 1. 2a to the power of 4 minus b to the power of 1. 5, choose 2. 2a to the power of 3 by minus b to the power of 2. 5, choose 3. 2a to the power of 2 minus b cubed plus 5, choose 4. 2a to the power of 1 minus b to the power of 4. And then last term, 5, choose 5. And then it's 2a to the power of 0 minus b to the power of 5. So whatever n is, if we start at 5, we always end at 5, choose 5. So it's always starting at 5, choose 0 and ending at n, choose n. So 5, choose 5 in this case. So again, we go to our calculators and we get 5, choose 0 on our calculator. And we know, obviously, if we go back to Pascal's triangle, that 5, choose 0 is going to be 1. 5 choose 0 is 1, 5 choose 1 is 5, 5 choose 2 is 10, 5 choose 3 is 10, and 5 choose 4 over... Sorry, just spotted there should be a 5 in there, obviously, and then the 1 at the end. Okay. So we have 1 times 2 by 2 by 2 by 2 by 2. So 2 to the power of 5 is 32. A to the power of 5, and then minus b to the power of 0 is 1. So anything to the power of 0 is always 1. 5 choose 1 is 5, and then we have 2 to the power of 4, which is 16, a to the power of 4, times minus b to the power of 1, which is minus b. We have 5 choose 2, which is 10 by 2a cubed, so that's going to be 8a cubed, and minus b squared. So that's minus b multiplied by minus b, which is, of course, just plus b squared. 5 choose 3 is 10. 2a squared is 4a squared, and minus b cubed. So that's minus b multiplied by minus b multiplied by minus b. So we have minus b cubed. And then we have 5 choose 4, which is 5 by 2a by minus b to the power of 4. And at this point you should notice that when we have a negative number raised to an even power, we always get a positive answer. And when we have a negative number raised to an odd power, we always get a negative answer. So in other words, minus b to the power of 5 is going to be negative. So we just have to tidy up now by multiplying out our brackets. So we have 32 a to the power of 5, and then it's going to be minus 80 a to the power of 4b plus 80 a cubed b squared minus 40 a squared b cubed plus 10 ab to the power of 4 minus b to the power of 5. So what you should notice this time is that we're alternating in signs there from positive to negative. So we just make a note there. A negative number to a even power is always positive, and a negative number to an odd power is always negative. Okay, so let's have a look at some. So note 1 is where the x term power is decreased by 1 each time from n to 0, whereas the y term power is increased by 1 each time from 0 to 1. The sum of the powers we saw there always equals n. In general, n choose or is going to have power of x will be n minus or, and the power of y is or. In x plus y to the power of n, there's always n plus 1 terms. So if we have x plus 2y cubed, then there's going to be 4 terms. We saw there in the last example that if y is negative, then we have to be careful to use the brackets for each term, because this is going to result in alternating signs from positive to negative. And another point to make would be that if we were asked to expand 1 plus x to the power of 4, for example, and the question then says, hence evaluate 1 plus root 3 to the power of 4, all you have to do there is replace x in your expansion after you have fully expanded it with root 3, and then just simplify as normal. So say, for instance, if we go back to the last one and we were given 2x plus 5, then y is 5. So at the end here, we would just put in 5 wherever there was a y.